My name is Trevor Fite, and I am an account manager. Brought to you by LiveLab Learning. LiveLab Learning is a subsidiary of Action for wholly applied software company, which we created to provide real manufacturing, and encourage you to interact with us by typing in questions and comments, of course, using the questions pane. We will be answering questions at the end of the presentation as well. Now, we'd love to have you connect with us and keep the conversation going beyond the event today. So we're recording today's session, and we will make the link available to you very soon after the recording. Next slide, please. I did want to mention before we started the webinar that we are going to have a class upcoming next month in May, the 19th to the 23rd in Atlanta at Applied Software's location. This class starts from the beginning with a blank screen. Basically, it teaches you the workflow involved in AutoCAD Electrical along with the picks and clicks as well. The class goes from 9 to 4 each day with a 1-hour lunch period. And if you have more questions, please do contact us at sales@asti.com. With that, I'll pass it to Randy Brunette, and he'll get started with the presentation. Randy?
Good afternoon, everybody. Laura, can you let me know if my screen is being displayed?
Yes, Randy, we can see your screen.
All right, great. Okay, so the brief overview of what we're going to be discussing today is like chocolate and peanut butter, Electrical and Inventor are better together. This is actually reusing this from Autodesk University this last year. I'll be the presenter today. Janice Spicer was my co-presenter for that class.
And Randy, so, let me know when you're ready to launch the poll.
Launch, excuse me?
The poll that for
oh, yes,
AutoCAD.
yeah, the survey. Yes, gotcha. Okay.
Yep.
Okay, so here's a brief introduction for myself. I'm an electrical subject matter expert with Autodesk. I've been using AutoCAD since 1984, AutoCAD Electrical since '96, and this upcoming year will be my 15th year teaching at Autodesk University. You'll notice the pictures on the slide. Mine's a little bit fuzzier. You are all very welcome. This would be a chance, Laura, if you can launch that poll. I just want to get a brief idea of what your experience is with the software. All right, I can't see the poll. Laura,
yes,
can you
yes.
give me some?
Yes, we're at 90% voted. So.
Okay. And what are the results?
We see 42% have used only AutoCAD Electrical, 15% has only used Inventor Professional, and 42% has used both.
Okay, great. So that's kind of interesting that both the electrical and the people that have used Inventor and electrical are the same number. So hopefully we'll encourage some of the rest of you to give it a try as well. Laura, if you can give me back the screen and let me know when it's ready.
Yes, Randy, you're up.
Do I have the screen?
Yes. Yes.
Okay, great. So there shouldn't be any more transitions. We should be good. I'll just continue on with the presentation here. So I'm going to zip through this kind of quickly. Again, just some things are better together, like electrical and mechanical, and of course the product design suite, which is going to include both Inventor Professional and AutoCAD Electrical. The secret to the interface with this is that you'll be able to complete a complete digital prototyping assembly from the controls and the electrical schematics through the mechanical design and the wiring inside the panels. This image that you see on the screen is one that's very interesting to me because it was my first up-close view at an explosion-proof cabinet. If you notice this electrical cabinet, it has almost 1.5 inch thick walls on it in order to prevent the explosions, and as a result the interior of the cabinet is extremely crowded, very little space between the components, and they have to do careful wiring, routing of the panels, the cables throughout the machine. Excuse me. So the two key parts, for those that are familiar with Inventor, the AutoCAD Electrical software does the electrical design, the control schematics. It creates the logical portion of your machine, including the connectors, symbols, the panel layout, and that's the area really where we start getting into the physical side of it, the layout of the components. And of course, one of the most powerful tools in electrical is the reports, the bill of materials, the wiring connectivity. For those that have used pretty much just electrical, the Inventor side of this really gets into the mechanical design, the physical components that are being created, the 3D real-world type of entities. They also give us the physical connections. We can see physically where the wires are attaching on the components, how the wires are going to be routed through the assembly, and finally we can take that information from that 3D design and get the physical characteristics from it to create things like nail boards and bill of materials that actually contain the length of the wires and components. To make this interface happen, so here's probably the most important slide of them all, we need to follow 5 guidelines to transfer information from Inventor to electrical and from electrical to Inventor. The first guideline, first rule, is that the tag name in electrical has to match the reference designator inside of Inventor. And I'll be showing all of these things in action as I through our presentation. Second rule, the terminal number in AutoCAD Electrical, which can be called a pin number, has to match the actual pin number on the component inside of Inventor. And again, what we're really doing there is labeling the components and where the wire is attached to. Guideline number 3, the wire type or layer name in AutoCAD Electrical has to exist or has to be created inside of the Inventor component as well, inside of the library. If it's not, we have error checking tools going in both directions that either automatically create the wire type or will allow you to select it and create it inside the library while you're inputting the wires. The last one, or second last one, is that the wire identifiers, the wire numbers in electrical, have to have wire numbers inside of Inventor, and that will happen automatically. If you create the wires in Inventor, they're automatically given a wire name. In electrical, it's a step we do to put wire numbers onto wires. And finally, the last rule is that the wires must be connected to both ends. They have to be attached onto a component. Especially in the Inventor world, you can't have a wire that would be imported that would start at one component and then just fade off into space and not end up anywhere. So there's no free wires getting given away there. Here's kind of some quick summaries of that information that's happening. So when we export from electrical, we're going to save that out to an XML file, and it's going to contain this information, right? Basically follows many of those 5 guidelines that I presented. The tag, the terminal numbers, the wire type, wire numbers, and the wire from to. That's all information that we get from electrical and goes into Inventor and be imported. When it goes in the other direction, when we're exporting from Inventor, it's also going to export the reference designator, which becomes the tag, pin numbers, the wire layer, and the from to report. So you can see they're very similar. Just how they manage the data going into the XML and being imported back out is what will change between the two. Okay, so that was the quick overview. I know it was real quick. Those 5 guidelines are real important ones, but I also know everybody's here to see this stuff actually working. So here we go. I'm going to start with a very simple schematic, a 3D component. This is what we're going to end up wiring. And I'm going to do that based on a drawing we're going to create in electrical. And here's where I'm really going to review those various rules and components. So in electrical, I have 2 connectors already inserted. I'm going to insert a third one. I'll come into here and set my spacing to what I need it to be and the number of pins and set the direction. I'm going to insert this component, and notice the tag names on here, 23X1, X2, and X3. Those will become more important when we get over to the Inventor side of this. Next, I'm going to add the wires between the components, and this is just a quick overview for those that aren't familiar with AutoCAD Electrical. Electrical has many tools that enable you to create wiring diagrams, control schematics very easily. Notice how I'm putting in wires, multiple of them at a time, allowing me to select the wire types. The routing takes place automatically. The connectivity between the different components happens automatically. So I can add these 10 wires that I'm putting in with just a few simple selections, selecting the wire types and the pieces I want to use. And finally, the last 2 wires I'm adding in down here are going to be 2 green wires. Okay, so what we've covered so far with our rules that we'll be transferring over into Inventor, guideline number 1, the tag names 23x1, 2, and 3 have to match. The pin numbers, so you'll see them 1 through 9 on this component, 1 through 9 and 1 through 5 have to match the pin numbers on the component in Inventor. We have to have wire numbers, so I'll add those quickly here, drawing wide. So each wire is identified to label it uniquely when it's being transferred over. The wire types you saw me inserting during the process, those are already existing inside of Inventor. And then finally, all of the wires are connected. So it matches all 5 of the rules. Now, once you have this schematic created, we're going to export that data to an XML file. It's a very easy process. I am just going to give this a name and save it in my Documents folder. So let me just jump up to there quick. All right, just grab it right here. And I'm going to call this ASTI. We're going to go from AutoCAD Electrical to Inventor Professional. From here, we're going to move to Inventor. Now, for those that aren't real familiar with Inventor, we can take any 3D solid and turn it into an electrical component simply by adding pin numbers to it. So in this schematic, you'll notice I have 23x1 that matches my electrical schematic, 23x3, and up here is 23x2. But notice it does not have pin numbers on it at this time. So that's what we're going to do, taking this solid and turning it into an electrical component. Simply highlight it, open it for editing, and you'll notice on our 3D model toolbar on the right-hand side there's these pin identifiers. These act very much the same as work points, how they're inserted and how they work. You can see the pin numbers coming into the spot. So I'm going to simply go through my component and add pin numbers to each one of the connection points where I want the wires to attach. I could use arrays or any of our other normal modeling tools with this component. So now that I have those pin numbers added, or pins added, that component is now going to be considered an electrical style component. And even notice, since I have 2 of them inserted, this one also has the pin numbers assigned to it. Notice the pins listed in the Inventor tree. This could have been done ahead of time, and you'll even see that in the next portion of this when I get to a slightly more advanced drawing. But again, this one's just the basics, kind of show that basic functionality of what's going to happen. All right, so now we have our harness assembly created. That is done simply through the Environments tab, and we can select cable and harness. Now, since I'm already in a harness, that's not available, but since I have a harness available here, that's what we're going to import the wires into. So back to my assembly. Let's see, I'm going to grab that guy real quick again. I've got to find my spot where I was back to import those wires. Oh, shoot, let's go here. There we go. On the harness tab, I'm going to import the wires. I'm going to browse to my Documents folder and grab that XML file that we created earlier. Here's the ASTI file. We'll open that. And now notice this imported harness data area. This read that XML file and brought all of the information from that file into our assembly. You'll notice these 3 markings here all have little warnings in front. That's because the electrical components inside of our harness assembly haven't been assigned the reference designator yet that matches up with the tag names that come from AutoCAD Electrical. And we can see that by simply right-clicking, seeing the issue description, and it describes what the problem is, and then by right-clicking we can also use one of the tools available to fix it. So I'm just going to assign 23x1, 23x2, and 23x3. And notice how the little warning triangles are disappearing. And if I expand these out further, there's the component with the pin numbers for each of the components. And if I run down to the wires, you'll be able to see each wire where it runs from the component and the pin and to the second component and the pin. That's all coming from that XML file from the schematic we created inside of AutoCAD Electrical. Just simply completing this process, and all the wires are routed through the assembly, and at this point they're just going straight from one connection point to another. Our next step is to tell Inventor how to route those wires through our assembly, through our component, our cabinet in this case, a machine, whatever it might be. We're going to do that using a function called segments inside of Inventor. These are going to look like the wire wraps, the wire ducts, and we just simply use 3D work points to establish where we want the paths to move throughout the assembly. I am picking the routing points based on my components. You can see how the points are appearing, and I'm going to go around the edge of the cabinet and end up on this second connector. Just zooming into here. Oops, let me turn that a little bit and select on that top point. Notice now how the wires are routed, or going to be routed through this area. Think of that as the wire loom. I also want to add one more segment. We're going to start from this point and have it end up on our third connector. Right, so there's our routing paths that are created. And lastly, we'll just tell Inventor to route all of the wires through the nearest conduits, and we can see how the wires are now pathed through the assembly. Right? Pretty quick, easy processes. And this all happened because of those 5 guidelines, right? The reference designators here, 23x, 1, 2, and 3, are matching the tag names in electrical. The wire pins on each component match, 1 through 5, 1 through 9, and so on. Wire types exist, and with all of that, the wires are then automatically connected, and then we route them. Now, once they are routed, we can do a couple of things to our component to help ease the transition, to make it look more like the wiring is going to happen. If you notice this component, for example, the wires are coming out from the end of the segment that I added and going straight the shortest route using a spline path to get to the pin. Well, obviously that's not how the wires would come in. Our wires would normally come straight out from the component and then kind of curve back into the assembly. So what we're going to do is go down and fix that. We're going to add some properties to our connector. So I move to edit the connector, and we are going to author that component and tell Inventor that it has a few more properties. It's actually a connector, and I want the wires to come out starting from in this direction. So they'll come straight out from the component and then curve following that spline path. So completing that process, you'll see now how the wires start initially out from the component and then curve and go back into the component. So there's a variety of tools for that. As we're going through the presentation, I'll try to show those where possible. So the next thing I want to do is, that's worked out pretty well on how the wires were able to be brought in from AutoCAD Electrical into our Inventor assembly. And even if I take a look down here at my assembly now, let's finish this guy. And I'll expand out my harness and take a look at the wires. Notice again, here are wires where they connect to in the solids inside of the component. So we've brought that information over, the tag names, so you can see the wire numbers, 10-9, 10-7, and so on, match the wire numbers that we assigned inside of our AutoCAD Electrical drawing. Next, we can also create entities, wiring entities, inside of Inventor, exporting that for use inside of AutoCAD Electrical and bringing it back in there. It's kind of taking the direction both ways. So what I'm going to do is take these 3 blue wires and delete those and replace them with a cable. Whoops. Let me get back to there. I just want to go back to my harness and just take out those 3 wires. Right, so those 3 wires out, I want to replace those with a cable. Moving up to our cable and harness tab, we can see we have the pin connections. So again, for those that are familiar with Inventor, these are pretty easy tools. And even those with electrical, if you start thinking of it in terms of the physical sense, what I kind of relate it back to is back in the days of the Radio Shack box where we attach wires with little springs. This is the same kind of thing, right? We're just attaching wires on the physical components to create our assembly. So from here, I'll take the black wire, pick the pins where I want it to run between, just like I would kind of do in the electrical schematic, right? Attach the wiring pins between the several different components. The only real difference is I'm doing it now in the physical world. So once I have those created, we can see there's my 3 wires, black, red, and white. And right now they look like individual wires because they kind of are, right? Any cable is made up of the individual wire pieces. But let's route this. Instead of the automatic route, I want to use this tool instead, because as I pick just the first wire, notice that all 3 wires are selected. Inventor recognizes this as a cable, treats all 3 wires the same way, so now it's a simple matter of determining where I want the wires to be routed, and they're routed through the component. Now that I have this assembly created, our next step is to export this back into AutoCAD Electrical. We're just basically reversing the same process we did before. I'm going to save it out to an XML file. In this case, we're going to go from Inventor to AutoCAD Electrical. Moving back to our mechanical assembly, I'm going to take out parts of this. Basically, I'm going to start from the same spot that I was at before, right? 2 connectors previously inserted, 3rd one missing but without any wires. From here, I'm going to read that XML file into AutoCAD Electrical. Select the file, the one we just created, and open it inside of AutoCAD Electrical. You'll notice here that 2 connectors, the ones with the X on the placed column, already exist in the drawing, 23X1 and 23X3. So we need to insert this 3rd one. So I simply have to select that, select the pin spacing. Notice the pins and the tag name information is already there. Insert that where I want it to be inside of my drawing. And our last step is just tell Electrical to wire that based on the Inventor information. Pretty amazing, right? Here's all the same information. We've taken these wires, exported them to Inventor, and basically re-imported them automatically. And notice our new cable. Those 3 blue wires we deleted are now replaced by this cable. Here's the 3 wires in the cable, and the cable tags that have all come from the Inventor side. If we just jump once more back over to Inventor, here, we'll be able to see those 3 wires are showing up in this harness as cable 1, 1, 2, and 3, just like they were inside of Inventor, or inside of AutoCAD Electrical. All right, so what we've done so far is we've started with an electrical schematic, albeit a very simple one, added wires, components, following our 5 guidelines to make sure we have the same ref tags, same wire pins, same wire numbers, exported that to Inventor, which is back in here, where we now assigned the reference designator codes where needed. Again, those could be pre-assigned or assigned during the processing, as you saw me do. Then we routed the wires through the cabinet. From this point inside of this harness, we then deleted those 3 wires and exported them into Inventor, or into Electrical, to recreate the drawing there. But before we go on, I want to show you a few more things we can do with that, namely creating a nail board drawing from this information. So once we have the harness created, and now that we have the physical data, we can create the wiring diagram that the Inventor assembly people would be using. So here is our nail board, and this has the physical dimensions and the pieces already assigned to it. So I'm going to even show that by adding a few harness dimensions to this. And again, this is where we can start creating the actual physical dimensions of the component, labeling the lengths of the wires, where they run, angles, all kinds of information like that. And not only that, but it has the intelligence built into it. So let's say I want to add a broken sketch entity. I want to shrink this up. Now remember our dimension here was 6 inches. We're taking out 4 inches of that, but our dimension still remains at the 6.7. It remembers what it was physically. We can pivot the information in here, again, to better facilitate how it would fit on the drawing, how you'd want to show the component. I can do that with either wires or as you can see, I did it with the entire segments. Let's see what else. Property displays. I can show the pin information, such as the pin name on the components. So there it shows the pin numbers. And even from here, one of my favorite things that I really like is placing the connector views, images of what each connector is going to look like. So not only do you have the pin number information, but you also have the image of what that component is going to look like. Again, to help the assemblers know what to do and how to create their assembly model. We can also create bill of material information that shows the components that we're looking for, lengths, that kind of thing, because we have the physical information available. From here, I'm going to go back and show some other tools, a little bit of the what's new inside of AutoCAD Electrical, as well as some of the changes that have made for this year to incorporate it in 2015 for our mechanical interface. So inside of AutoCAD Electrical, I'm going to move to a simple drawing here. For those that might not have seen the updates from 2014, we can now work with and manage distributed type of components. You'll notice this relay here with 3 contacts. And to show you some new functionality, I'm going to delete one of the contact sets from here, and I'm going to insert that back in. So I'll go to our new catalog browser. Again, this is new for 2015. You'll notice that it allows you to do a freestyle kind of search. So I'm inserting a motor starter, just entering a couple of numbers that I happen to remember from the part number, AN16D, and it searches through the database and comes back with all of the part numbers that match that AN16D. You can see Eaton and so on. From here, when I select that component, this dialog pops up that allows me to select the type of symbol that I want to insert, whether it's the coil or the child. And one of the neat parts about this as well is we have these favorite tabs that are here. So I'm going to remove it from the favorites list because I want to show how easily that can be added. So by simply picking on it, I can select on the plus with the favorites, and now the next time I want to get that part number, I don't even have to remember this information. I can simply select on favorites, and anything I have saved to that list will show up here. This is very handy because most of the time your most common part numbers are probably 20 to 30 different part numbers. And I know everybody uses more of that overall, but the most common ones are going to be relatively small numbers. We can simply save them to a list, pick straight from that list, and then select the component we want to insert. That same editing area, it provides a one-stop shopping for all of the edits you want to do. So you don't have to go back to all those different databases. That interface is going to do it right from there, including even pin number information that shows up automatically, right? Just like AutoCAD Electrical did before. Next, we're going to follow the same process that we did before. We're going to save this out to Inventor. And in this case, again, I'm in my documents. We're going to call this ACE2, and I'm going to call it distributed to kind of show that, to just separate this file from some others we're going to work with. So we can hit save from here. And now again, I'm going to move to the Inventor side and open up this assembly. It's a slightly different assembly than the one before, a little more complicated, has a few more paths. And you'll notice that that motor starter that I'm talking about doesn't exist in this component. This is another change that's updated for 2015 in the Inventor environment. We can now use an electrical catalog browser. Basically, the same interface you just saw me use in Electrical is now available in Inventor for selecting the parts. So from there, I'm going to go up to my Place component and select the Electrical Catalog Browser. The same rules apply. Again, it is the same interface. So just by entering a few letters or having it saved as the favorites and doing a search, you'll see the component list appear. I simply select the part number I want to work with, and even a little image of that part number shows up when the part has been established in the Inventor libraries. Simply click on it, and it automatically finds that component and places it into my assembly. So this is our first step in improving that interface between Electrical and Inventor, allowing you to use the same interface. So as you're working between the two softwares, it'll make it easier for you to use and to provide a commonality, an automatic way of getting that list of components from one environment into the other. Now inside of here, I just need to constrain that to my model. So I'll just use some of our constraint commands, starting with the insert option and placing it onto the hole in the assembly. And then I simply need to orient it into the assembly correctly. And I've placed my part, just like any other parts. And again, this one has the pins already saved on it. If I rotate it around, you'll be able to see some of the pin connections and the pieces that are in here. Now, once it's in my assembly, it's just like I was doing before in that other simpler assembly. Now I can create a harness, add the routings, and just in the name of efficiency, I already have many of those routings inside of this cabinet. You did see how I was doing that. And I'm going to import that data that I just exported earlier, right? That distributed file. Same process is going to be followed. And here again, we can see our electrical parts. This one, since it was just inserted, we can see there are all the pins, but it doesn't know which component in my assembly that 101K6 belongs to, right? So there's the issue description saying it wasn't found among the parts, but I can easily, right from the dialog box, even insert it directly from the part catalog, or I'm just going to assign it to an existing part, pick on the component, and it's now corrected. It knows what component the wire and pieces are going to run through. And again, just like before, we see all the wire numbers that are assigned and running from and to each different component. From here, same rules apply. The wires that go directly from one component to another in the straightest, shortest line possible. And then we just establish the routing of the wires using those segments and the harness paths that you see inside of the component. And the wires are all routed between the assembly. Next, I just want to talk a little bit about how we can route these wires and make them a little bit easier. Again, you see how it comes out of the piece and goes straight into this assembly. And there's 3 different ways you can manage that. I already showed one of them, and the first one is just editing that component and giving it that wire direction. So I'll start there to manage those 2 wires. I'll take that component, the same one as we were working with before, and author it as a connector, picking the surface where I want the wires to come out from, right? Same arrow direction. And those wires are now routed coming out from the component and going back into my harness assembly. Next, I'm going to work with these 3 wires that are coming into this area. Now, one is going just fine, right? It comes out from the end of our harness or our loom straight into the connection, but these other 2 need to curve around. So what I'm going to do with those is add work points onto the components. So I'm going to add a work point onto each component, or each wire, I should say. And then using our simple 3D move commands, we can now determine where we want those wire paths to be run. And you can see it changing live as I'm editing with the component, or with the wire again. And just repeat the process with the other wire. This gives you a great deal of control over how you want the wires to be routed through the assembly, determining shortest paths, most convenient paths, and so on. And finally, the last way I'll show you to try to route the wires is just to be more precise with the actual segments or the harness loom itself. You can see in this case we have the 3 wires going in. What I'm going to do is just add some additional segments onto that to force the wires to follow certain paths. Right, so I'm adding 3 segments here between these 3 pins. And lastly, I just need to route those wires through those pins. So I'll unroute them from their current path plan that they have. And now I can use the automatic route one. I don't even have to pick the individual spots because the wires go through to each spot automatically. Right, so with those tools, the wiring tools, notice how the wires automatically are routed using the splines to go between the different connectors, different components. We can see how we can manage the tool pieces and control the paths in a very precise manner. And I'm actually finishing a little early, which is great because that allows us for a little extra time for questions. You can type the questions in, and Trevor and Laura will be monitoring and feeding them back to me. Laura and Trevor?
Yes, can you hear me now, Randy?
Yes.
Okay, I moved inside, and I do apologize to everyone on the call for the Wi-Fi issues we had earlier. You may hear some background noise, but we're open for questions, so if you have any questions, please type those in the questions panel in your GoToMeeting panel over there on the right-hand side, and we'll try to get those answered for you. Okay, Randy, we do have one question that came across. The question is, does the diameter of the wire routed in Inventor update based on the wire gauge defined in AutoCAD Electrical?
Yes, well, it's more combined with the 2 of them. As you noticed inside of AutoCAD Electrical, in fact, I'll switch over there to show that, the wire gauge is determined in Electrical by our Edit Wire tool, and we determine the width in here. Physical components, diameter is not stored with this information. It's basically the layer type and the layer name. So the information isn't necessarily coming from Electrical, but it'll come from the Inventor library. So the Inventor contains the physical portions of the wire, the diameters, the components. When you define that wire type inside of your content center, and that also will change the diameter of the segments as you're passing them through the area. So you might have noticed some of the segments changing sizes as only 1 wire was routing through it or 3 wires. But all that physical sizing comes from the Inventor library component, the actual physical sizing of it. Great question.
Another question that's come across from a couple of participants is where you can find the recorded session. We will record the session. We're recording it now, and we will pass that along once we get that downloaded, and we'll send that link to everyone who's attending today.
One of the things I'll add on to that is that since I did reuse this information from the Autodesk University class, you can also go to the Autodesk University website. You'll be able to download all of the data sets, the AutoCAD Electrical data set and the Inventor data set that were used for most of this presentation.
One other question we just received is the Inventor file a part of the project we opened in Electrical?
No, they are 2 separate files, 2 pieces that you're working with. One is the electrical project file, but the interface between the 2 is through that XML file. So they're not linked in any other way other than through the XML file.
Okay, just a couple of moments for some more questions. We'll wait for those and ask them as they come across. While we're waiting for those, I did want to mention that you should see on your screen that we do have an AutoCAD Electrical class coming up in May 19th through 23rd. If you want more information on the class, please send an email to sales@asti.com. It's a very popular class. We generally fill that class pretty quickly. We do have, I believe, 4 or 5 spaces left in that class, and it's a very good experience starting from the ground up in AutoCAD Electrical all the way through to creating a project. Okay, I see we have no more questions. We do want to thank you for attending, and if you would, on the last slide here, please look for LiveLab Learning on YouTube. Subscribe to our channel. We do post a lot of webinars that we host through that channel on YouTube. And again, thank you very much for attending today.